perspective and also just this quantitative perspective, or qualitative perspective. So let's consider it in terms of Q and K. So suppose our volume is decreased by a factor of 2. Let's just make it easy. And we have constant temperature here. So this change will increase the partial pressure of both gases, the reactant gas and the product gas, and it's going to increase them both by the same amount, by 2 initially. So let's look at our equation for Q, the reaction quotient. We have partial pressure of products over the partial pressures of the reactants, raised to the coefficients of the equation. So initially, you're going to increase the pressure, partial pressure of both gases by 2, the product by 2, the reactant by 2, but here it's 2 squared. So overall, Q becomes a half. So Q decreases by a factor of 2, and so Q becomes less than K. And so in the clicker question, we talked about what happens when Q becomes less than K. And what happens there is you're going to shift toward products until Q equals K again. So you can think about this in terms of Q and K. You can also just think about it, how many moles of gas are on one side, how many moles of gas on the other side, and how are you going to correspond, how are you going to decrease or minimize the stress on the system. All right, so let's think about what happens if we increase the volume. So here is our system, and now we're going to expand it. If we're going to increase the volume, what's going to happen to the total pressure? I'm hearing it, but I want everyone to answer. Thank you. All right, so we'll decrease the pressure. And what that's going to do is shift toward reactants, because we want to compensate for that decrease in pressure. And to do that, we can increase the pressure by switching or shifting the reaction toward the reactants. So again, we're going from 1 mole of product on one side to 2 of the reactants. So here we see a shift toward the reactants. And so this shift to the left is going to increase the total pressure to compensate for the decrease in pressure that was a result of this applied force to the system. And we could do this again in terms of Q and K. Now we're going to get a little trickier. What happens if we add an inert gas to a system increasing the total pressure at constant temperature? So we're not adding one of the reactants or one of the products. We're adding an inert gas, and we're increasing the total pressure. What's going to happen? There's a couple of options. What do you think? How about nothing? Why would nothing happen? Well, Q depends on the partial pressure of the reactant gas and the product gas. And in this particular example, the partial pressures are not changing. We are changing the total pressure of the system by adding an inert gas, but we're not changing the partial pressure. So let's take this opportunity to